Okay guys, today we're going to talk about terms and like terms and identifying and combining like terms. So when we are talking about like terms, these are each a term, and that other column is also, but in this case, we have a coefficient, which is the number that hangs out with the variable. We have the variable, and then some of these are to a power. For the most part, what we're going to work with for the rest of this unit are not going to be to a power, and they're called linear because if we graph them, they make a line. But in this case, we're just going to talk about this. So this is the coefficient, this is the variable, and this is the power. In order for them to be like terms, they need to have exactly the same variable to the exact same power. So here, let's start with 3x squared. What we're going to look for in this other column is another x to the second power. So we can look down through there and you should see that this is the like term right there. So I'm just going to write x to the second power right beside that because those are the like terms. So here we have 5b cubed. And I've made the same mistake again. This should say b cubed. I intended for that to be its like term over there. So 5b cubed and 4b cubed are like terms. So again, I'm just going to bring this over here to be beside its like term. And so 6r, r is to the first power. So again, this is negative 6r, this is to the first power. We just normally do not write that to the first power. So I want to give you guys a second to look at this and see if you can identify the rest of these like terms while I write those up there. So I have gone ahead and I've written up the next set of like terms. So this one was like to 7m to the first power. Again, it didn't matter that the coefficients did not match. This one was x to the first and b to the second. So what I also want to talk about just for a second is combining these like terms using addition. So I'm going to go ahead and erase this column so that we can come over here and combine these like terms. So here I have 3x squared plus x squared. I want to combine those. First, you have to understand that every little variable has a coefficient, even if it's just chilling there and looks like it doesn't. This has a coefficient of 1. If it were negative x squared, it would have a coefficient of negative 1. So 3 plus 1 is 4x, and it stays to the second power. This one, 4 plus 5 becomes 9b cubed. Now here, I have 6 plus negative 6. This might be a good time for you guys to go back to using your T-chart and putting the negative 6r on the negative side and the 6r on the positive side. We know that since these are different signs, we subtract and we get 0r. But the actual simplified version of this, we know that anything times 0 is 0. So this would be the simplified version, or if this were in an expression that we're simplifying, we just would leave it blank completely, that this one is equal to nothing, but for this purposes, let's say that it's 0. Again, I'm going to pause it for a second and let you guys finish those other three. So as you guys can see here, I have combined my like terms. Here I use my T-chart just to make sure I understood they were in separate columns and that it was going to be a positive 2m. This one right here, again, I used the T-chart, and it ended up being a 2, and it did not end up being a 2, it ended up being a what? a 1, and it should be negative. So it could be written as negative 1x or negative x. And then 7b squared plus negative 7b squared, we should recall that these are what are called a zero pair, as were these. So this just simplifies to be 0. If this were in another problem, again, you could either write it as 0, but just know that probably it's just going to be left off completely.